Hello and welcome to Haybridge Maths Department, A-Level Year 2. We're looking at pure. We're continuing working through Chapter 5 on radians, and I'm going to break this next section, which is 5.3, the area of sectors and segments, into two videos, and we're going to start with sector area today. In the next lesson or the next video, we will look at segment areas. The difference between a sector and a segment is a sector goes to the center. So if you've got a sector, that's a sector there, whereas this here, where it doesn't go to the center, is a segment. So this area here is a segment, this area here is a sector. So let's get started then and look at sectors to start off with, and then we'll use our knowledge of sectors to work out the area of segments. So when we're working in radians, the formula for the area of a sector is really straightforward. What you do is you take the radius, you square it, you multiply by the angle measured in radians, of course, and then you take half of that. And that will give you the area of the sector. So what I'm going to do is I'm going to give you three examples now, and I am then going to do the proof of where this comes from, and we will leave it for the first video on that. Okay, so let's get on with three examples. The first example is very straightforward. You've got a load of words, tells you that the sector has a radius of 2.44, it's got an angle of 1.4, and it wants us to work out the area. So what we do is, first thing we do is we draw this out here. So we say that that's 2.44, that is 1.4, and then if A equals a half r squared theta, then all you need to do is take those numbers and plug them in. So you do half times 2.44 squared times 1.4, and when you do that, you get 4.17, and I do believe it's centimeters squared. So if you haven't done so already, press pause, take that down. It's probably a good idea to make sure you've got the definition, which I forgot to tell you to say pause on, but do get that into your notes first of all, then get this into your notes. Once you've done all of that, we will look at another simple problem, but this time it's about doing a little bit of reverse work. So press pause now if you haven't done so already, otherwise let's have a look at example 12. Okay, so this time we've got the area. We know that this area in here, because it says minus sector, this area here is 28.9 centimeters squared. We know that the angle there is 0.8 radians, and all you have to do is reverse everything. So A equals a half r squared theta. We know that already. So you've got a half times 2.44 squared, and that was the example from last one. I've just copied down the wrong one. Do make sure that when you're doing an example, you're doing the right example. So right, back on with this one. We know that the area is 28.9. You've got a half there, and r squared, well, we don't know that, and we're timesing by 0.8. I think what happened there was I was a bit distracted by the seagulls. I don't know whether you heard them in the background. But anyway, we're back on track with this. All you need to do now is take that 28.9, multiply it by 2, divide it by 0.8, square root, and if you do that, you get R equals 8.5 centimeters. So we got there, and it is just another rearranging question. I hope very straightforward. Right, next example. If you press pause, make notes on this, and then we will have a look at the last example to do with sector areas. Again, I hope really straightforward, but we've got a plot of land. This plot of land happens to be fortunately in the shape of a sector, and it's got a radius of 55. We know that the perimeter along the edge of a plot is enclosed in 176 meters. So we want to now work out what the area is equal to. So let's draw out what we can see first of all. So if we draw out here, and I don't know, call this O, A, and B, we know that this has got a radius of 55 meters. So there's 55 there and there's 55 at the bottom. And we know that the total perimeter is 176. So it's not that AB is 176, but it's a total perimeter. So the total perimeter is that 55 between OA, and it's a 55 at the bottom, taken away. So I should say that 176 is AB plus a 55 plus a 55. So to work out AB, you take 176 and you take away 55 for OA, and you take away 55 for OB, and that leaves us with AB. So let's work out AB now. So we've got 176 minus 2 lots of 55. So take away 110, which leaves us with 66 meters. Okay, so we know from the previous videos that the arc length is equal to r theta when we're working in radians. So AB equals r theta. So we know that 66 equals 55, because that's the radius, times by theta. And what we've got now is that theta equals 1.2 radians. And that means that if theta equals 1.2 radians, we know the radius, we can now go on and work out the area of the plot. So we now know that the A equals a half r squared theta, and A equals a half times 55 squared times 1.2, which equals 1815 meters squared. And there you go. There's the area of the area of the land. So we've got that there. Last thing that I want to do on this video, or I should say, by the way, if you haven't done so already, it's becoming a bit repetitive, but pause and make notes on this. If I just put this here, and you can pause at the different points to take notes on this if you haven't done so already. And then let's have a look at where it comes from. Why is it a half r squared theta? So on this, you've got the area is going to be, the area of a sector So the sector area, excuse my handwriting, is going to be the fraction of the circle multiplied by the area of a circle. If you can read that. Okay, so the fraction, we know that there's 2 pi radians, as we've seen before, in a total area of a circle. So we are going to do theta over 2 pi for the fraction of a circle, and the area of a circle is going to be pi r squared, of course. Then we can see that the pi's cancel, but this time we do have the 2 still on the bottom. So if we just rearrange that, if the pi's cancel, then you have, well, let's actually write it out like this, theta over 2 r squared, but we don't normally write this like that. We write a half r squared theta. Okay. So there you go, quite a straightforward proof, quite an easy one to do. Make notes on that if you haven't done so already. And then I will be back in the next video where we've got some more complicated examples, I would say, where we look at segment area. So see you next time. Goodbye.